Alright, so I've decided to make some videos here to help you all out with some of these homework questions. If you're having issues with domain restricted graphing, I'll try to keep this up throughout the semester. Don't hold me to it though, because everyone here is strapped for time. But I'm going to put it in for y'all, try to make sure I can get y'all up to speed here if you're having issues. But what we're doing here is our domain restricted graphing. Again, what tells us it's domain restrictions is when you look right here. Right, we have some inequality. It says graph f of x if x is greater than -2. Right when you see something like that, you need to know, yeah, we're doing domain restricted graphing. But if you remember from the notes, what we're going to do here is we're going to start by just dealing with this f of x equals x squared. All right, so the first thing we're going to do is if we look at that, f of x equals x squared, hopefully you're able to identify that because it's to the second power, that's telling us that it's quadratic. So we start by identifying our graph there. It's quadratic, which means it's a U. It either opens up or it opens down. Right now, obviously, we should be able to tell which way it opens pretty quick there. There's no negative sitting out in front, so it's going to open up. So just so we know where we should end up. That's step one. We identified it. Step two is now where's that starting point? We always want to start with the starting point before we do the restrictions. Again, the starting point is there anything added on to this equation here? Now, a lot of us get tripped up here, but there's no +3 telling us to go up 3. We don't have x plus 3 in the parentheses squared telling us to go left 3. So because we don't have something that looks like this, x plus 2 squared plus 4, which I know everyone could look at that and say, oh, left 2 up 4, there's nothing added on. That tells us our starting point is 0, 0, right? So I'm going to put starting point, or what we call the vertex. Vertex is 0, 0. So I'm going to put that down here, and then I'll put a little reason why. Vertex is 0, 0, no translation, right? Nothing added on. And give me a break if I have a little bit of issues here while I'm trying to write. I have this. They gave us these new tablets, and I'm trying to figure it all out right now. So our vertex is 0, 0. We can add that onto our graph. Okay. Now the second part. After we've done this, this is step one. This is step two. We usually go through and use the table, but before we do that, this is where we're going to change. We look at what's the restriction. So now we're dealing with this restriction for our domain. It's telling us we want a graph where x is greater than -2. So the first thing I need y'all to do here is just go to -2 for x, and we're going to draw in a line telling us where that restriction is happening. Right? That's at -2 right there. Now, after we do that, what we want to do here is look at the inequality specifically. Right now, since it's just a greater than sign, right? We just have a greater than sign. That's telling us that for that point at -2, once we get there, it has to be open, right? Because it's not included. It's when we add that or equal to on those signs, that's what's telling us we need to fill in the point. Okay, so if it's just greater than or less than, open points. When you have the or equal to, it's a filled in point. And the last thing that this inequality here is telling us is we need to graph where x is greater than -2, right? So if this is where -2 is on this line that we've drawn here, the question is, are we graphing on the right side or the left side of that line? The easiest way to think about that is this greater than sign is essentially an arrow pointing you in the direction of which way you need to graph, right? So we're going to be graphing on the right side. That's where we're greater than -2. After all of that, we can go through and do our last step here and graph this. Now, this is quadratic, which means it's a curve. We can't use the slope. Just make sure you don't try to use the slope here. We have to use the table, right? So we're going to use our table here, plug in a value for x, and we'll get a value for y. Our vertex, again, I like to start with that in there. That vertex was 0, 0. Now, usually we would just go, oh, plug in 1, and then we'll move from there. But this is the other difference with domain restricted graphing. When we're using the table, because we can't just use the slope, the value we're going to choose to plug in comes from the restriction, right? So we're going to actually plug in that restricted value of x, so -2. We're going to actually plug that in instead of plugging in that next value, only for domain restricted graphing. So I'm just going to write plug in -2, that's the restriction. So we always are going to plug in the restrictions because that's going to get us to that point there. So we're going to plug in -2. Again, we're taking -2, we're going to plug it back into this original equation of x squared there, because that's what f of x is. -2 squared. -2 squared is +4. I'm sorry, I don't know why I put that parentheses there, giving us the coordinate point, -2, +4. Right, so we can graph that. We go -2, +4, and this is good, right? We end up on that restricted line, which is what we want. We want to end up there. I always start with these points on the restricted lines is very, very noticeably big and open. We check down, it has to be open because it's just a greater than sign, so we're going to leave it like that. And that's all we really need to finish off this graph, because what we know is quadratics, they are symmetric. So if there's this point that's up 4 to the left 2 over here, then we can go up 4 to the right 2, and that gives us that right side of our quadratic. And I'm going to try as best as I can right now to draw this U. Hey, that was all right. That was all right. Again, we only go to the right of that restriction, which is why we don't have the left side of that quadratic popping out over there, right? We have it start at the restriction, go to the right, because that's where it's greater than. But that's the graph done. Now, if you went through and you did the domain and range, if you read the directions, we're supposed to do domain and range as well. For our domain, again, domain is our x values. We look at what's the farthest to the left our x value goes, and that's our restriction, right? -2 is the farthest to the left it goes. And at -2, we have this open point. So open points, parentheses. Now we go to the right. How far to the right will this graph go? You look at it, it is going up, but it is slowly going to the right, very, very slowly going to the right. It hits that arrow telling us it's going to the right to infinity. That's our domain. For our range again is our y values. You look at what's the lowest y value we have here. That's that vertex, right? That graph will never go any lower than the vertex. That's at a height of 0. And at that point, it's filled in. So we put a bracket. So that's the lowest point. We see how far up it goes. That graph is going to go up, up, up. It's going to hit that arrow. It's going to go to positive infinity there. We don't have to stop at this value of 4, even though there's an open point, because along that line, yes, we have an open point right here to the left, but right here to the right, we have a filled in point. So we don't have to stop that interval there. We can move past it. But that finishes up that first problem. We'll go through a little bit quicker on the next few, but hopefully this is helping you all out. All right, so now we're looking at this example over here. This is number 2. We have f of x equals x. Now the first thing you need to do, again, for all of these graphs and any time we're graphing ever, is you look at that equation and hopefully you're able to identify that because it's just x, we don't have the squared, we don't have any absolute values, x isn't in the exponent, that only leaves us with one last thing: it has to be linear, right? So we know it's linear, and then that's our first step, identifying that. The second step is, where is that starting point going to be? So just like we did on number 1, notice how there's nothing added on. I put 0. There's nothing added on. There's no +3. There's no in parentheses x minus 3, right? Nothing added on. Again, telling us that our starting point is 0, 0. So I'm put starting point 0, 0, nothing added on. Very similar to that previous example. Nothing added on. So we can go, we know that starting point is at 0, 0. Perfect, right? Those two steps follow the same suit. This is where we start changing it up. This is domain restricted graphing again. That's because it tells us right here, graph f of x. So we're graphing that line where x is greater than -1. I'm pretty sure that's the same exact restriction that last problem had there. So since we have that restriction at -1, that's where we're going to draw this dashed line here. Oh, you know what? That last one was at -2. Whew. All right, I'm not losing it yet, y'all. Our restriction's right there at -1. Again, right at this point, I know we need to restrict the graph at -1. I want to look at, because that's just the greater than sign, right? Because it's just a greater than sign, what that's going to tell us to do is keep it as an open point. It's only when it has that or equal to is when we're going to fill in those points. So at -1, when we get there, it's going to be open. And then the last piece, you just look at it, right? If it's greater than -1, are we graphing on this right side or are we graphing on the left side? Hopefully, again, you can just know that greater than -1 is going to the right, or you can always think of that greater than sign as an arrow pointing you kind of in the direction that you need to go there. Sorry, I'm trying to like change colors there. Right, it's a greater than sign is pointing you graph to the right. After that, step 3 for our linear graphs is it's quick, right? Linear graphs, we should always be happy. Step 3 is just use the slope, right? So we look at what number is sitting in front of our equation here. Again, if there's no number sitting there, that's when we say there's a 1 there. There actually is a slope. The slope is 1, whole number, you put it over 1, so we rise 1, run 1. And the only thing you have to do here is make sure you go all the way to the restriction. So if we use the slope, we go up 1, right 1, we go up 1, right 1, but we need to make sure we go to that restriction. So go back to your to that starting point and instead go down 1, left 1. That's the same exact slope. That changes nothing. So we can put that noticeably open point. We check down, we know it's supposed to be open, so we can finish off our graph. It's a line, sorry, it's a line we graph to the right of -1. That's as straight as I'm gonna make it there, trying as best as I can, but that's that domain restricted graph. Now to finish this off, what we're gonna do here is the domain and range. All right, so for our domain, we look at how far to the left does it go. The farthest to the left this graph goes is right there at x equals -1. And at -1, it's an open point, so we use a parentheses. Now we say how far to the right will it go. Nothing's going to prevent us from going to the right to infinity there. And then for our range, we look at what's the lowest value this goes. It happens to be -1 again. And it's a parentheses because that's an open point. And just like the domain, this graph will go up and to the right until infinity. So that is your range for that problem there. Okay, so we're going to look at number 10 here. Same process that we just went through. First step, you look at this graph. We know it's domain restricted because we have that -1 is less than x is less than or equal to 5. Now, you look at this, right? We know f of x is absolute value of x minus 4 minus 2. If you read it, it's telling you what kind of graph it's going to be. But first, let's start off by identifying this is a linear absolute value graph, which means it's going to be a v, right? It's either a v that opens up or a v that opens down. Hopefully, just by looking at that equation, we know that it opens up, right? Because there's no negative number sitting out in front. So it's a v, it opens up. Step 1 is done. Step 2 is, where's that starting point? Where's the vertex, right? Now, when we're looking for the vertex, what we want to do is look at what's added on. And I think we're getting pretty good at finding the vertex here. You look at that x minus 4, right? That's telling us to go to the right 4. And that minus 2 is telling us to go down 2. So we're going to go right 4 and then down 2. That'll tell us where the vertex is. We're going from 0, 0. The only time we translate from 0, 1 is exponentials. So we're going to go right 4, 1, 2, 3, 4, down 2. Right there's the vertex for our absolute value graph. Okay, so if we want to put the coordinate point, if you want me to do that, we could do that as well. That's the coordinate point for the vertex. after we graph the vertex or the starting point, those are the same, I just use them interchangeably there. It's the vertex for absolute values in quadratic. What we're going to do is now look at what's that restriction, right? So we have those restricted values at -1 and 5. Again, remember what this means is x is between -1 and 5. So what we're going to do is we're going to only graph in between -1 and 5. So I'm just going to go over here to -1, draw in where that restriction is. And again, when I draw in that restriction, it's at -1. We look at it, it's just a less than. It doesn't have the or equal to, which means it's going to be open. We'll do the same for the 5. We look at, now we have 5, there's a restriction over there. At 5, drawing that restriction line. Yeah, trying my best here. That's at 5. And now look, whew, for the first time here on that homework, we have the less than or equal to. Because it's or equal to, we finally get to fill in one of our points here. So that's a filled in point at 5. Okay, that's just going to help us when we go through and finish off that graph. So we have the restrictions in place, we have the vertex. The last step, and why we love our linear absolute values in our lines, the last step there is to use the slope, right? Use slope to finish. We don't have to use a table because this is linear, right? So use the slope. Again, to find the slope, we're looking at what's that number sitting out in front of the absolute value. Because there's nothing there, that slope is 1. So our slope is 1. Make that a whole number, 1 over 1. Rise 1, run 1, and the only thing you have to make sure you do here, go to the restrictions on each of them. So we go from the vertex, I'm going to go up 1 to the right 1. Again, I always start with that really, really big, noticeably open point. Check down there. We know it's filled in because that one had the or equal to, so you actually just have to fill in that point. That's the right side of our V. The left side, right, we go up 1 to the left 1 now, right, and then just keep going, up 1, left 1, keep going, right, we need to go all the way until we get to that last restriction point, which is right there. Oh shoot, what am I doing? There we go, it's noticeably open, right? We check down, again, we know it's open because it was just a less than sign, so it's going to stay just like that, and we're going to draw that straight line connecting that, giving us a V, right? Now I know that doesn't look like a V. That's because we restricted the value, right? If we extended this past, there's your absolute value right there. It's just we cut off a part of it. If you cut off a part of a V, it gives you kind of a check mark there, right? You cut it off, we have a check mark. So that's why it looks like that. But it's still an absolute value graph. But that's the graph done. For the domain and range for this graph, right? Domain, again, is our x values. We look at what's the farthest to the left it goes. Now notice how the x values are related to that domain restriction, right? We're restricting the domain. Farthest to the left it goes is -1. And at -1 it's an open point, so we're going to go with a parentheses there. And then we look at how far to the right will it go. It's not going to infinity, right? This is the farthest right point right here. That's at 1, 2, 3, 4, 5. And at that point it's filled in, so we use a bracket, okay, for our range, our y values. Now we look at what's the lowest point. Now we're talking about the lowest point on the graph, which is this vertex right here. That graph will never go any lower than that vertex, so that's our lowest point. That's down at what, -2 for our range. It's a filled in point, and now we need to see how far up will that graph go. So the highest point our graph reaches is this point right here. It'll never get any higher than that because we restricted it to that value. And that's at a height of 1, 2, 3. Noticeably open point telling us we got to put a parentheses there. But that's the range for that function. So y'all should be good. If you have any questions, let me know. Alright guys, looking at number 11 here. Again, it's domain restricted. You look at this restriction right here, that's telling you that. The second thing that we need to do here is figure out what that graph is. You look at it, it says f of x equals 2 to the power of x minus 1. Look at that right there, it's telling us what kind of graph it is. x in exponent means exponential. So I'm going to go over here, write exponential. And the biggest thing about exponentials, we don't start from 0, 0, we start from 0, 1. That's huge, right? That's 0, 1. That's what changes up our exponential graphs. That's the first piece. The second piece is, what's that translation? So you're going to look at what's added onto the equation. In this case, we have -1 telling us to go down 1. So we're going to go for the starting point, down 1 from, again, this is huge, 0, 1. That's massive, right? So we're going to go from 0, 1. 0, 1 is right here. Okay, we go down 1, and that's where we end up, right underneath it. Now, that's when we put in our asymptote, which is one step below it. And just like we do for exponentials and for these, just like we do for all of our domain restricted graphs, now we're going to work with this restriction. So we have a restriction at -1. So I'm going to draw that dashed line at -1. At -1, it's just less than, so it's open. Sorry, that's a 1 right there. We have a restriction at +3 for the x, so we go to +3, we draw that restriction line. That's there at +3. This one has the less than or equal to, so that's one of our filled in points. So now we know when we get to -1, it's open. When we get to 3, it's filled in. And this is where step 3 of graphing exponentials, we have to use the table. You cannot use the slope here. And watch what happens here. We have something interesting happen. You might have gotten stuck here, and hopefully that's why you're watching this video. We set up our table. We cannot use the slope. We always start with that starting point. Sorry, not that starting point. That's where we find the translation from that starting point that we found, which is at 0, 0. So that starting point for our graph is 0, 0 because of the translation down 1. And what we're going to do, again, is plug in those critical points, or sorry, those restricted values. So we have the restriction at -1 and at 3. Now I'm going to start with the 3. Okay, we plug in 3 for x. We're plugging it into this equation, right? 2 to the 3rd power minus 1. 2 to the 3rd power is 8, minus 1 is 7, giving us the point 3, 7. So we know on this restriction at 3, we go up 1, 2, 3, 4, 5, 6, 7. Again, I'm going to put a real big, sorry, let me use a different color. I'll use green here. I'm going to put a real big open point at 3, 7. We check, oh, at 3 we're supposed to fill it in. It has less than or equal to, so I'm going to fill that in. Okay. Now we're going to plug in -1, the other restriction, and yes, this might get a little bit interesting. So we're going to plug in -1. We're going 2 to the -1 power minus 1. Now, 2 to the -1, if you don't remember how negative exponents work, to make that positive, you push it to the bottom of the fraction. So that actually is going to become, let me go over here, 1 over 2. If you punch it into a calculator, 2 to the -1 power is just 0.5, which is 1/2. We still do minus 1. 1/2 minus 1 is -1/2. So we end up with a interesting point. It's -1, -1/2 if you want to write it as a decimal. -1, -0.5. We have to graph that. So we're going to go -1 and then down halfway. And we should end up right in between these points. Now again, I'm going to make it a noticeably open point. It's going to look strange here, but we make it noticeably open because we check down here that restriction at -1. It is open, so we leave it like that, and we can draw our graph. Sorry, I keep holding it. We can draw our graph. Now that's just a piece of our exponential graph. What else we have to do here is notice how our asymptote is outside the restriction. We're just going to get rid of those pieces that are outside of our restricted lines as well. We only need it to be in between those two restricted lines. Again, when you're plugging in this -1, 2 to the -1st power is -1/2, or sorry, 1/2. But we can do domain and range now. For our domain, You look at what's the farthest to the left it goes, that's -1. It's an open point at -1. The farthest to the right it goes is +3, and at +3 over here, that's a filled in point. So we go bracket. Now we do our range, and this is where the range is going to be interesting. The range, we look at what's the lowest this point reaches. It gets all the way down here, and in this case, that's at that height of -1/2, right? That's where that height is. So the lowest point on our range, -1/2, but we put a parentheses because it's not filled in. Then we go to the highest point, that was at 7. Sorry, 7. I put a parentheses. Hopefully you notice that. Everybody, you're wrong, you're a dummy. That's a bracket, it's filled in at 7. So that's our domain and that's our range. If you had issues with that 2 to the -1st power, that's alright. Again, 2 to the -1st power is equal to 1/2. Okay, but that should finish off that problem for you, and then I'll move on to the next one. Alright y'all, here we go. We're looking at number 12 now. It's another domain restricted graph. What tells us it's domain restricted is this, again, this right here, that's our restriction. It's saying we're only graphing f of x where x is less than or equal to -2. Now we're still going to go through just our regular steps of graphing here. We look at this, it's telling us that f of x, our graph, or our function, is x plus 4 squared minus 3. Now I stopped and said squared like that because that's telling us what kind of graph it is. Because it's squared, that means we're dealing with a quadratic here, and quadratics, they look like U's, okay? First step is done, we identified it. Second step is, where is that vertex? Now, to find the vertex, that's when we look at what's added onto the equation, right? So in this case, for that vertex, we have x plus 4 there, telling us to go left 4, and -3 to tell us to go down 3. So I'm going to write left 4, that's a F, left 4, down 3. Now I don't recommend us going -4 and -3 right off the bat because keep in mind for exponentials we translate from 0, 1, so that throws off that little method of just chucking the vertex in immediately. So we're going from 0, 0, it's quadratic, we're going to go left 4, 1, 2, 3, 4, down 1, 2, 3, and we should end up right there. There's our vertex. Okay. After that second step of finding the vertex, that's when we're going to go through and use the actual restriction, right? So we're going to look at it. We're graphing f of x only where x is less than or equal to -2. So the first thing we want to do is go to -2, draw in that restriction line saying this is where we're going to cut off our graph at -2. The second thing we can say is at -2, because it has that or equal to sign, that means it's going to be filled in when we get that point on the restriction. And then the last thing it tells us is where to graph, right? Again, less than is pointing us in the direction to graph to the left, right? So we're graphing to the left, that's what less than is telling us. So with all of that, we know that our graph should only be on the left side of that restriction. It should be filled in when we get to the restriction, and then we should be able to finish it off from there. So the last thing that we're going to do to finish off this graph is we set up our table, right? We set up our table, x and y. This is where I like to follow that process of what's the coordinate point for our vertex. So our vertex is at -4, -3. We already have that point. We only need to find one more. And usually following our standard protocol, right? This is when we'd be like, okay, let's jump up one, plug in -3, right? But notice how -3 is going to put us on this line right here. We want to be all the way over on the restriction. So instead of plugging in -3 like we usually do, the difference is for domain restricted graphing, we plug in that actual restriction, right? We know it's going to go to -2, so we'll plug in -2 there instead of -3. So we'll plug in -2. Again, we're plugging it into this equation up top. So we're going to go -2 plus 4 squared minus 3. And we should be able to work that out. -2 plus 4, +2 squared minus 3. 2 squared is 4. and 4 minus 3 is 1, giving us a coordinate point -2, +1, which we can now graph, right? -2, +1. Again, when we put these points on the restrictions, make them real nice and big and open. Then we check, oh wait, at -2, we're supposed to fill it in because it has that less than or equal to. Fill in that point. And after that, we can actually finish off this graph. It's quadratic. So since we have that point that's up 1, 2, 3, 4 to the right 2, we can go up 4 to the left 2. That gives us the left side of our U. And with that, I'm going to give it my best shot here to draw this. Oh, we got kind of sketchy there, but that's our quadratic. Notice how we only went to the left. We did not draw this piece off to the right side because that's greater than -2. We don't want that. Now, one last thing I want to say before we finish off this problem is sometimes, right, had that restriction, instead of being x is less than -2, been x is greater than or equal to -2. Nothing else changes though. Vertex is in the same place and everything. That's weird, right? Because now it's saying, oh, we need to graph to the right side of -2, but your vertex is on the left side, so it already messes you up. Still though, graph your vertex at first. Right, then you'll graph your start, or then you'll find that point at -2, just like we did. We'll still have these 2 points here, the vertex and this point on the restriction. And what you're going to end up doing is you'll end up with some graph where you start from your vertex and you come up through that second point, and it's just like the right side of your quadratic. But specifically, up that right side, we're only going for this little bit here from -2 to the right. So you would only have this piece in yellow here, which is okay. All of this we would get rid of. But in this case, that doesn't happen. But no, that is possible, and stuff like that can happen. The last thing we're going to do here is domain and range. For our domain, again, that's our x values. We look at how far to the left will this graph go. It's going up and to the left forever, meaning it's going to -infinity for our x's. The farthest to the right it goes is here at -2, at this restricted point. And that restricted point is filled in bracket. For our range, the lowest point this reaches is down at what? 1, 2, 3. That's where our vertex is, -3. That's filled in, bracket, and it's going to go up to +infinity. Finishing off that domain and range for that problem. Hopefully that helps you out there with number 12. All right, here we go, number 13 here. This one is writing equations now. So we're not going through and doing the graph. Now we have the graph of a domain restricted function. We will write the equation. But if you remember from the notes, for writing equations, we just start off by writing the equation for this function here, which is a check mark. Hopefully you notice that that's just an absolute value function that's been chunked, right? If you take a v and then you eliminate parts of it, it can end up giving you a check mark, which is why it looks like that. So this is linear absolute value. And because it's linear absolute value, we start with that base equation of y equals m absolute value of x. That's what gives it the v. After that, we go through our steps, right? We just identified it. Now we find what's the vertex. Where is that vertex? What's the translation, right? So to get to that vertex, we go from 0, 0, we go to the left 1, 2, left 2, and then we go down 1, right? That's the vertex. This has nothing to do with the slope. That's a translation to get to the vertex. We go left 2, down 1, right? So we have to add that translation of left 2, down 1 into this equation here to translate us left 2, right? Left or right, we attach it to the x. So let me get rid of this absolute value for a second. To go left 2, we think opposite there, so x plus 2, and we can close that in there. Now it's attached to the x. We got x plus 2 telling us to go left 2. To make us go down 1, that's when we just attach it onto the outside. Down 1 is a -1. So we have this equation, y equals m, the absolute value of x plus 2 because that vertex was left 2, -1 because it was down 1. And to finish it off, really nice thing here about linear absolute values is they're linear, right? If it's linear, we can finish it off by just finding the slope, right? So we're just going to figure out what's the slope and we'll plug it in. So the slope is the rise over run. So we just have to count from the vertex, rise over rise, rise over run. We just have to count from the vertex. So here's our vertex. To get to that other point, we go down 1, left 1. So our slope is -1 over 1. Notice why it's negative. That's a v that opens down. If it's a v that opens up, it's positive. -1 over 1. We can just write it as -1 and substitute it back in. So that equation is actually y equals, our slope is -1, absolute value, x plus 2 minus 1. Again, with that -1, you don't actually have to write it. So we're going to take that equation and put it right up here where it says f of x, again, not writing the y. So we're just going to put negative, I'm not going to write the 1, we don't have to, absolute value of x plus 2 minus 1. That's our equation there. And then the only piece that makes this different is this, right? This isn't just the graph of that function, it's restricted. So we're going to add in that restriction. So we're going to draw the restriction lines in. It's cut off right there. That's at -3. At -3, that is a filled in point. Okay, it's also restricted over here at +1. Right, this is where the graph is being cut off. At +1, again, look down here, that is a filled in point. So to write our restriction, right, first off, it's graphed in between -3 and +1. So our restriction for x, 3, 1, the x is going to be in between it, right, because that's where it's graphed. These are always going to be less than signs when we have this joint restriction of 2 of them. And because both of these, in this case, both of them are filled in, right? Because both at -3 and at 1 are filled in, that's when we add the less than or equal to's, right? Had that been an open point there, then we just leave it as a less than. But because it was a filled in point less than or equal to, and that finishes off the restriction there. So writing the equations just follows that process that we do for all of our equations, and then all we do is add in that restriction there at the end. All right, y'all, here we go. This is the last one here. You should be able to hopefully get through all of your homework. Hopefully you didn't have to go through every single video, but if you did, hopefully it helps you out. But we're ending on one last problem here. It is writing the equation, and let's jump into it. So first thing you look at this, hopefully when you're looking at this graph here, you notice that it's a quadratic that's just been like chopped up, right? That's what domain restrictions are. They're chopping up our graphs. It's quadratic. We always have to start with that step of identifying, because since it's quadratic, now we know that base equation we use is y equals ax squared, right? That's where we start. What we're going to do after that is add in the translations. Right now, again, what I recommend is you write the translations. Don't just write a coordinate point for the vertex, because when we get to exponentials, that's where it gets real funky. But let's find what that translation is to get to the vertex. Now the vertex is right here. They should have put a point there to make it a little more obvious. But hopefully you figured that out. To get to that vertex, we go what? Oh my gosh, what's happening? We go to the right 1, and we go down 1, 2. Again, that has nothing to do with anything about slope, which doesn't even exist on this. That's just how we're describing how to get to that vertex. Right 1, down 2. After we find that translation, we need to add it into the equation. To translate us right 1, we attach it to the x, which means, give me a second here to get rid of that squared. We attach it to the x, right? Put it in parentheses, go right 1, we go x minus 1. And then we're going to add that squared right back in. You just put it right there. Don't forget the squared. That's what makes it quadratic, right? X minus 1 is right 1. To make us go down 2, we go onto the outside and we just add that minus 2. So now we have the vertex, right? It's right 1, down 2, added that into the equation. Now when we do this next step, we use that entire equation. We keep the translations, we start there. You have to start with the translations. So I'm going to rewrite this here so we know that we're just working with this equation after we've added in the translation. Now to finish this off, we have to find out what's that a value, which is like the stretch of this graph. It's not the slope, we can't count it, though sometimes it seems like it works out. For this, for step 3, you have to use the other point. Right? In this case, the other point is here. That's at 0, -1. So we're going to use the other point 0, -1 to find a. Again, what we do there is 0, -1 is another point on the graph. You cannot use the vertex. We're going to plug in 0 for x, -1 for y into this equation here. So I'm going to plug in -1 for y, 0 for x, and I'll rewrite it right below. So we should end up with -1 equals a, in our parentheses, 0 minus 1 squared minus 2. And we should be able to work this out and solve for a. 0 minus 1 is -1. A equals -1. -1 squared is +1 equals -1. And right here, you cannot subtract. We can't do 1 minus 2. That a is being multiplied to the 1, so we can't do that subtraction there. Be careful. What we do there is we add 2 to the other side. -1 plus 2 is +1, and we get a equals 1. We get a times 1 equals 1, but a times 1 is just 1, so a equals 1, right? Giving us that value that we're going to plug right back in to our equation here. We'll plug it back in, and I'll rewrite it over here in red. Our equation is y equals, that a is 1, x minus 1 squared minus 2. Now this 1, we don't actually have to write it because that's going to, it's like that invisible 1 in front of a slope. Like if you have an x like that, there's technically a 1 in front of it. We don't have to write it, so I'm not going to write it there for our equation. And we're just going to take that, substitute it right up here for f of x. So we go x minus 1 squared minus 2. And to finish this off, the last thing is, this is all domain restrictions, right? So first, let's draw the restrictions. Now, this first one is being restricted at 0. Okay, so it's being restricted at 0. At 0, it's a filled-in point. So I'm going to make that note. Now, the second restriction, I wish they would have made it a little more obvious for me. My apologies. I'm going to assume that there's a filled-in point there. They should have put a coordinate point, or they should have put an arrow, because that's two completely different ideas. So we'll do first with this as a filled-in point, giving us a restriction at 3. Okay, so it's a restriction at 3, it's filled in. So if that's our restriction, what we know is it's only graphed in between 0 and 3. That's where our x is. These are always less thans, and because they're both filled in points, that means at 0 and at 3 we put the or equal to's. Okay, so that would finish off that problem. Now, if they meant for this to be another way, so I'm just going to look at the second case. So in case they meant for this to be an arrow, which they should have made it obvious, right? If it was like that, now we have a different restriction, right? Now our only restriction is at 0, right? So our only restriction there is at 0, and it's how is that related to our x, right? So if that was the case and it was only graphed like that, notice how that's only graphed to the right of 0, which means that's greater than. Again, when you draw that arrow to the right, there's your greater than sign right there. So if that was the restriction, we would say x is greater than 0, and at 0 it's filled in, so greater than or equal to. I'm not sure which one was meant there. I will accept either of those answers. If you did that filled in point, that was my initial reaction, so it would be that first. If you thought that was an arrow that meant it went to infinity, then this would be your restriction there for the graph. But hopefully that clears it up, and hopefully that helps you out with that section 5 homework.